couple new enzymes here in gluconeogenesis, and up here. That allows us to apply separate regulations. You can make these regulatory enzymes, and you can put regulatory controls on this first step here, just like you have in glycolysis up there. So you can, through allosteric regulation, you can turn on one pathway and at the same time shut off the other one. Both are possible, but that's the way you want metabolism. You want both directions of any metabolic scheme to be possible. You want to be able to break down fat or make fat at will. The cell decides which way you want to go. You have to be able to break down glucose or remake glucose at will. It's a question of what makes sense. Both are theoretically possible because they're both energetically downhill. It's just a question of what regulatory dials you adjust. So by putting regulatory enzymes in glycolysis that are separate from the regulatory enzymes of gluconeogenesis, you can switch one on and the other off at the same time. So they're not working at cross purposes. And so, for example, here, the first step, hexokinase, it's inhibited by allosterically by glucose 6-phosphate. Well, if you look over here, the equivalent enzyme in the synthesis pathway, glucose 6-phosphate, stimulates that. So the same intermediate acts to shut down glycolysis and stimulate gluconeogenesis at the same time. Or down here near the bottom of the pathway, near pyruvate, in the gluconeogenic direction, acetyl-CoA is an activator. In the glycolipid